Hi, welcome to the second episode of how to make good figures for thesis and papers. Again, about the traveling tournament problem. It is part two, but you can probably watch this video independent of the previous video. So let's go. Okay, this is a schedule of the traveling tournament problem. We have 4 teams here on top, and they have to play each other team twice. Once at home and once away. You can see that here, once at home and once away. And that is the notice the double round robin constraint. Then there's the max streak constraint, and that says that you can at most play 3 times in a row away or at home. And then there's the no repeat constraint, and that means you cannot play the exact opponent in consecutive rounds. And as you might know, might have seen by now, there are some constraint violations in this schedule, but that is exactly the idea that we want to convey. The problem with the traveling tournament problem is that we don't have a uniform random sampling algorithm. It is very hard, let alone optimizing a schedule, to find a valid schedule in the beginning. And this is a problem for genetic algorithms. The thing that we tried to investigate in the paper from these figures was, how big is this problem actually? How big is the problem of finding a valid schedule that abides by all the constraints, but randomly selected for the traveling tournament? And for that, we did some experiments. I'll go through them later. But I want you to look at this example first, because there is a thing with this example, and it's principle number 9. And principle number 9 says, choose your example strikingly but non-trivial. And this example is not strikingly chosen. And the reason for it is that what we should ideally have is a constraint violation of every type exactly once, because that makes it the clearest to your reader. But the problem is, with this schedule, we have a no repeat violation here, a no repeat violation here, a no repeat violation here, and a no repeat violation here. Another problem with this schedule is that we have a max streak violation here, but it is also a double round robin violation, because the Red Sox are being played twice at home, so one of these should be away. Now, why is this a problem? Because it is slightly confusing. But as nature might have it, it appears that there is no schedule, that there exists no schedule of 4 teams that has every constraint violated exactly once. It might not exist at all. Let me show you what Chris has done in his experiment. What he has done is he's taken a number of teams, like we just saw 4 teams, but you can also take 40 teams, or 42, or 44, or 50 teams. Put the opponents randomly in the schedule. You can do it either rows first or columns first, and then just see how many violations we have. So if we sample completely randomly, how many violations do we get? And you can see this line. This is the average number of violations. Every number of teams has been sampled 1,000,000 times, and you can clearly see that the double round robin violations are most prevalent in making a schedule invalid. Now, to take you through the steps, I would like to show you version number 2 of this figure. And there's a few very important details, a few slightly important details. One of them is that we changed the word home away streak for max streak. And that is because now the legend in the figure is identical to the text in the paper. The second change is the number of digits. Like we have 3 decimal places here, 0 decimal places here. This could even be gone. And we moved it out and it looked neater. And then in the third version of this figure, Chris made these nice little insets. And look at how the distance from the border here is the same as the distance from the border there. Took us some time to find out that that looks best, but it does. Okay, there's the citation. We always need the citation. And one thing that you need to look at is it has no border around the figure itself. And that looks a little bit sloppy in a presentation or a video like this, but for the paper itself, it's very important because it allows you to cheat a little bit in the margins. And if you do have a border, it shows very quickly if it's either too small or too big. Trick. Okay. So then we looked at how many samples do we require, and Chris just resampled and resampled and resampled and resampled and watched the number of violations go down as he kept the best instance that he found. And well, here you see that on the horizontal axis, or don't say x-axis when there's no x, it's a horizontal axis, that the number of schedules generated runs from 1 to 1,000,000. And you see that ever better schedules are being found. With some function fits in there, it's not important for now. But what is important is that the colors of this second figure are identical to the colors of the first figure. And also the order in which the legend runs through the various items, first total, then double round robin, then max streak, then no repeat, is the same as in the previous figure, right? And that is all done to lower the cognitive load. Yes, and to do so, you should keep the colors and the shapes and the meanings and the styles and the orders constant throughout your paper. If the double round robin is red in this figure, the double round robin is also red in the next figure, and in the third figure, and in the previous figure. And it's no coincidence that double round robin is red and not double round robin is blue, because it sounds more alike. Okay, so then we looked at the distribution of these violations, like do they all occur evenly often when we sample? And it turns out no. There's sometimes we just have a lot of violations, sometimes we have very few violations, and the distribution looks bell-shaped. And all these figures, they give us some insight into how big this violation problem actually is. And here you see 4 teams, here you see 6 teams, and here you see 8 teams. And you can already see that it looks much better for 8 teams than for 4 teams. Now for the paper, we decided to go for the highest number of teams. Here it is, 50 teams. And you can see that it looks much better and it drives the message home like these distributions are bell-shaped. That's the insight we got from these experiments. And to drive that message home to your reader, you should make these, you should pick the most appropriate graphs and just supply the others on your repository. So it's not cherry picking. We're not giving any false representation, but this drives the message home best. And then the final version of the figure, you should see there's just a little change in order. The total is going to the top left. And then the round robin comes, and then the max streak, and then the no repeat, because that is the way you read. So that is the order. And again, you can see that the order of items is identical to the order of items in the previous figures. So it ties together like a nice composition, right? And one of the learning points here is that if you take larger numbers, so for instance 50 teams, like bottom right, it makes for smoother graphs than the top right. It is not false representation to choose your larger graphs. The principle is still true, also for the smaller numbers, but it drives home the message better and easier. Okay, so now if you look at the whole thing, then you can see that these three figures, they sort of have a relationship to each other. It's always total first in green, then double round robin in red, then max streak in blue, and then no repeat in yellow. Very, very contrasting colors, but the meaning is always the same. The order is always the same. And this accounts for some cognitive load. It makes it easier to understand your paper, and it abides by the view of visual storytelling. Yes, and for that, and that's the last thing we're going to do, I'd like to run through the paper a bit so you can really see what it looks like in a published paper, right? So you can see on page 2 there is the figure. This is an older figure still from a previously published paper, and the idea is to immediately make the reader understand what the traveling tournament problem is. Yes, 2 pages of text, that's a little bit and then there's the required number of samples. Then there's the distribution of the violations, and now you can see very clearly that if you scroll through the paper and you're just looking at the figures and you're just looking at the title, you already have a pretty good idea of what's in the paper. It lowers the cognitive load tremendously, right? And there's the third one, and there's this table. Maybe we should have put that there. I'm not really sure about it. Okay, and then we come to the end of the paper. Okay, and so here in one overview, you can clearly see how consistent these colors are and how easily you can visually read the paper as a whole. This is one of the most important things I would like to tell you if you're my student, maybe even if you're my colleague, like make your paper visibly readable. Yes, abide by the principle of visual storytelling. There we go. All this flying stuff. Isn't that nice? The end. Thank you so much.